Alright, so this video is for my students who are trying to get them to understand and to be able to do the process of completing the square. So remember, completing the square is actually, its entire purpose is to be able to go from standard form of a quadratic equation or of a quadratic. So we're going to refer to y equals ax squared plus bx plus c, but we can apply this to any quadratic expression. But we're going to be able to go from standard form to vertex form. So y is equal to a times x minus h squared plus k. Now remember, in vertex form, it's called vertex form or graphing form because the vertex is easy to identify. It's the hk value that exists right here. So remember, this is minus h, so we've got to switch the value to get the h, and then this is plus k, which is the same thing, goes right there. So what we're going to be doing in this video is to be able to take this form, standard form, and rewrite it into vertex or graphing form. Okay, then we're also going to be working on factoring, which is taking the quadratic equation in standard form and rewriting it into factoring form. This is something hopefully you've been having spent a lot of time in. It basically is something we do a lot with the quadratic equation. And being able to use the zero product property in solving it. So first we're going to focus on completing the square. Alright, first let's look at it geometrically. Basically what I mean by that is we're saying complete the square, and square is a geometric shape, so let's think of it that way. So let's say we have a square, and pretend like that's a perfect square. I don't know if my dimensions are a little off. And basically what we're going to do to this square is we're going to divide it into 4 parts. Okay, so what's going to happen here is to complete the square, what that means is that this side right here has to be equal to this side right here. So we need to have equal dimensions. Well, first of all, this corner right here, we're going to pick a corner. I'm going to say that it's the bottom left corner, and I'm going to say that this is my x squared corner. And so however many, I'm always going to put x squared right there. And then this corner over here is always going to be my constant, so non-x values. And what that means is this other diagonal is going to be split up into 2 equal x values. So let's look at this in terms of a real equation. We're going to start simple. Let's say we have x squared plus 8x plus 7. Okay, so when I'm going to say this constant, I'm actually going to always have it missing. So basically what I mean by that is that this constant right here isn't going to play a role until the very end of my equation. This is kind of different than how people normally teach this, but I think a lot of ways that this is consistent, so this might be easier to understand. All right, so I don't have anything in this corner right here. So now what I need to do is I've got my x squared right here, and I need to split my 8x into 2 equal parts. So basically when you think about that, that means that we're going to take this and we're going to divide it into 2 groups. So that means I have 4x here and I have 4x here. Okay, so if we ignore this corner of the constant missing and we just look at these 3 portions of the square, and we start factoring it out or saying what are my dimensions of each square or each rectangle, I'm going to say that, okay, x squared would be x by x, so x times x is going to give me x squared, and then 4x, that gives me x over here, and so what factors out of 4x is 4, and then same thing, this is x here, and so this side would be 4. And so we can see what we have is that this bottom dimension is x plus 4, and this left dimension is x plus 4. Okay, but what is happening here is that this square should be 4 by 4. So what we're missing, so it's minus from the square 4 squared. All right, so now how do we put this into equation? So what we have is an x plus 4 by x plus 4 squared, or x plus 4 squared, but we're missing 4 squared. Okay, and then this is where I said this comes in at the very end. We say plus 7. So now our equation is, we're going to set it equal to y. Y equals x plus 4 squared. And then we got minus 16 plus 7, which will give us minus 9. And that is now in vertex form. And our vertex is at negative 4, because remember, it's got to be the opposite of this, comma, negative 9. Okay, for our next example, we're going to talk about what if there's an a, or if there's a leading coefficient that isn't 1. So let's say our quadratic expression is 3x squared plus 12x minus 10. Okay, if we're still thinking about this geometrically, this 3 basically means that we're looking at completing 3 squares, and these 3 squares all have to be equivalent with each other. So if we draw this out, we have 1 square, 2 squares, pretend like these are all equal to each other, and 3 squares. And we're going to do the same thing. We're going to divide each of these into 4 sections. And each square gets an x squared. So we know that that means that this is x by x, this is x by x, x by x, and we also know that this is missing, so we're just going to put a question mark in its place. Okay, now, remember, these squares all have to be equal to each other. So what that means is this 12x, to fill in the other diagonal of our square, we need to divide that up into 3 equal parts, 1 for each square. So we're going to do 12x, and we're going to divide that by 3. And so what that means is this square gets 4x, this square gets 4x, and this square gets 4x. Okay, so what we basically have is x squared plus 4x, and we have to complete that square. So remember, now that we divided it, the x's equally amongst each square, we then have to divide this quantity, 4x, by 2 to be able to get how much goes into each part of the diagonal, the 2 different sections. So we're going to divide this by 2. And so that means that this section gets 2x and this section gets 2x. 2x and 2x. 2x and 2x. All right, so if we finish our factoring, we know that this side is x and this side is x, and this is x and this is x. And you can see that if we could just write one square, this gets really redundant because they're all identical to each other, but I want to show you how it all works. Okay, so now we need to factor out the other side. So 2 times x gives us 2x, and so this will also be 2, 2 and 2, 2 and 2. So then basically our dimensions are, this is x plus 2, this is x plus 2, this, and that's true for all of them. All right, so now final thing is we know that this is 2 by 2, and this is 2 by 2, and this is 2 by 2. So all of our sides are equal to each other. So that corner that we're missing is 2 squared, or 2 by 2, or 2 times 2. And we're missing 3 of these. So that means that we're going to have minus, because we're missing it, 3, 2, by 2 or 2 squares. Okay, so now let's talk about how this rewrites. So we have 3 squares that are each x plus 2 by x plus 2 or x plus 2 quantity squared, and we're missing 3 corners that are 2 squared. Okay, then remember we talk about how, okay, we deal with this constant at the very end. So we're going to put this at the very end, do minus 10, and then we're going to simplify. So 3 squares that are x plus 2 by x plus 2 minus, okay, so this is 3 times 4, which is 12. So we got minus 12 minus 10, or negative 12 minus 10, so that gives us negative 22. So that tells us that this parabola, its vertex, is at negative 2, because remember it's always got to be the opposite, negative 22. All right, let's do one more geometric example. So let's say our quadratic equation, we have 5x squared minus 10x plus 1. Okay, so in this example, I'm going to show, since basically the previous one, we had 3 squares that were all the same thing, I'm going to think of it as, okay, I'm going to have 5 squares, so 5 times, and it's all going to be the same, but I'm only going to draw one of them. So my 1 square here, we divide it up, and I'm going to have x squared. All right, so we know that this will be x and x. Okay, then remember what we had to do is we had to take this 10x, or negative 10x, and we had to divide it amongst the 5 squares. So we're going to divide that by 5, which means that each square gets negative 2x. Okay, so this is, actually let's get rid of that. This is how much for each square. And then when we divide this by 2, that is going to give us how much for each corner. So that means that each corner is going to get negative x. And then remember, this is missing. So we're going to say whatever this ends up being, we're going to subtract it. And we're going to subtract it 5 times because there's supposed to be 5 squares. So 5 times whatever this ends up being. All right, so let's put our x's around. You don't have to do this every time. I'm just doing it to show consistency here. Normally, I would only write out these 2 x's if I'm going to do this geometrically. Okay, so because we have an x right here, then that means that it is going to, its other dimension has to be negative 1. And so this is also going to be negative 1 right here. Sorry, that's not supposed to be x. This one is supposed to be x, and this is supposed to be negative 1. Okay, so now we got that sorted. All right, so what that tells us is that the square each side is x minus 1 by x minus 1. Okay, so we know that we have x minus 1 squared. We have 5 of those, so that's why we have the 5. And we are missing, okay, so this would be negative 1 by negative 1, so a negative 1 squared. So we are missing 5 negative 1 by negative 1, or negative 1 squared, and then we bring over the last number, the constant, plus 1, and then we simplify that. So we still have 5x minus 1 squares minus, so this is 5 times 1, because negative 1 times negative 1 is 1, so this is going to be minus 5 plus 1, so this is going to be minus 4. So that tells us our vertex is at 1. Remember, the opposite, negative 4. And that's where our vertex is at. Okay, what if you're tired of drawing squares? Or if, sometimes the numbers don't work out and you've got to do other things, like you're going to have a fraction or a decimal. So let's talk about how you can do this just algebraically, just with writing it out in terms of equations and using the math. So let's say, let's just start with an easy one, x squared plus 10x minus 4. Okay, if you remember, the first thing we did is we divided it up into equal numbers of squares, but because we only have one square here, we're not going to have to divide 10x by something into equal number of squares. So our first step in this case, because we do not have a leading coefficient, it's 1, so we're only dealing with one square, is what we're going to do is we're going to just divide this into 2 groups, okay? So, if you guys remember, when we did that with a square, so I really am tired of drawing this, but we're going to go with it. We had x squared and we had 5x and 5x. What happened is that our dimensions actually ended up being x and that coefficient right there, x plus that coefficient, or whatever we got for a coefficient when we divided this. So we can kind of use that knowledge right now, and we can say, okay, I have a square that's x plus 5 by x plus 5, or x plus 5 squared. And then the corner that was missing always ended up being that number as well that we just, when we did 10x divided by 2, that coefficient, it was always that squared. So we can say, okay, we're missing 5 squared. These numbers match up, but this is always going to be subtraction because we're always missing it. And then we bring our constant down. And then we simplify that, and so we have x plus 5 quantity squared. This is 25, so we have negative 25 minus 4, so minus 29. And our vertex is at negative 5, negative 29. Okay, so now let's talk about what do we do if we have a leading coefficient. So we're going to start out, next easiest number is 2. So let's say we have 2x squared minus, let's go with 8x plus 24. Okay, so basically what we do here is, if we were factoring, we would take out a common factor of 2, but since we're not doing that, remember, we just ignore our constant until the very end. Okay, so in this case, we have to divide it up into 2 squares. So basically what that means is we're going to take this quantity and we're going to divide it by 2. And so we're going to write that as, I have 2 squares, and in both squares I have x squared and I have minus 4x. And then we've got our 24. Okay, now we're going to complete the square with what's inside of the parentheses. So this is where we divide by 2. We divide it into our diagonals, how much goes into each diagonal. So this right here takes us to, okay, we have negative 2x in each diagonal. So that means it's gonna, negative 2 is gonna factor out. So what we're gonna have here is we have 2 squares that are x minus 2 by x minus 2, and we're missing 2 corners of negative 2 squared, negative 2 by negative 2. Remember, these numbers match up. And then we have plus 24. So then if we simplify this, we end up with 2x minus 2 by x minus 2 squares. This ends up being 2 times 4, which gives us 8. So we have minus 8, or negative 8 plus 24, which is going to give us plus 16. And so that tells us our vertex is at 2, 16. Okay, obviously not all numbers are divisible by 2, and not all numbers are going to be divisible by the leading coefficient. So let's say we have that kind of a circumstance. Let's say we have 3x squared. Let's first start out with not divisible by 2. I don't want to do plus. Minus 9x plus 13. Okay, so remember before, what we did is we divided it into 3 squares. So we divided this by 3. And we said, okay, we have 3 squares, and each squared has x squared and minus 3x. And then we got our plus 13. Okay, so now our next step is we have to go and figure out how much goes into each diagonal. So we divided this by 2. Okay, so that's going to give us a fraction. So basically, I think it's better if you leave it as a fraction instead of writing it as 1.5, because squaring fractions is really easy, and with calculators right now, adding is pretty easy too. So what we've got when we do this is we've got 3 squares that are going to be x minus 3 halves squared, and then we're missing 3 corners that are 3 halves by 3 halves, so 3 halves squared. Remember, these numbers match up. This should be a negative right here. You really don't have to put the negative in, because when we square it, it's going to be positive, so that answer will always be positive. Just so you guys know, and if I ever forget to put it in, plus 13. Okay, so now we just have to simplify this. 3 halves squared is 9/4 times 3 is going to give us 27/4. And then with 13, we need to make that out of 4 as well. So it's going to be 4. We're going to multiply this by 4 over 4. So it will be 4 over 52. So what we've got is negative 27/4 plus 52/4. And we're going to simplify that. So we get the answer of 3 times x minus 3 halves squared plus 25/4. And so our vertex is at 3 halves, 25/4. All right, so that's the example when our x values aren't divisible. Let's look at when our x values aren't divisible by the leading coefficient. Okay, so let's say we have 5x squared plus 12x plus 3. All right, so first step was, remember, we got to divide it into 5 equal groups. So we have 5 squares. So we're going to have 5 squares that are each going to have x squared. In this case, now 12/5 x. And then we got plus 3. Okay, and then remember, we got to divide the x's into 2 equal groups. So we're going to divide this by 2, which, remember, is basically 12/5 times 1/2, because dividing by 2 is like multiplying by 1/2. And we can reduce this fraction because we can cross divide here. And so this is actually equal to 6/5. So what that means is we have 5 squares that are x plus 6/5 quantity squared, and we're missing 5 corners that are 6/5 by 6/5, so 6/5 quantity squared plus 3. Okay, so I'm going to do a little math working my way down here for this section. So this is going to be negative 5 times 36 over 25. We're going to put this over 1 plus 3. Okay, once again, we can cross divide here. So this is going to end up being negative 36 over 5 plus, okay, now we got to multiply this by 5 over 5. So 15 over 5, so we can get a common denominator. And then remember, from here, we add the numerators. So this is equal to negative 21/5. So our equation is, we have 5x plus 6/5 squares minus 21/5. And so our vertex is at negative 6/5, negative 21/5. And that's how you would complete the square in this case. Just remember, really, the key behind this is that. Okay, so let's wrap up this process of completing the square. So basically, if you think about this, is we have y is equal to ax squared plus bx plus c. Mainly, when we're doing this process, we pretty much ignore the c, and we subtract a certain value from it as we're completing the square. Then the other thing that we do is we always factor out a, and we're left with x squared plus b divided by ax. Okay? That's one of our first steps, is we always do that. Then this leads to our next step of dividing by 2. So we're going to divide this quantity right by 2, or it's the same thing as multiplying by half. So we still have a out front, and as soon as we divide this by 2, that is the same thing as geometrically when we break that into two quantities and we put it into the two corners, and we can factor that out, and we realize that our square now becomes a plus b over 2a by a plus b over 2a, or that's our dimensions of x plus b over 2a squared. And we're missing that corner of b over 2a squared. And then we put a out front because this represents how many of squares that we have. So we have a x plus b over 2a squares, and we're missing this many squares. So these two numbers right here should always match up, and then these two numbers should always match up, and they should always be squared. And then we should have plus c. And basically that's the process that we follow when we are completing the square. And then we simplify, and that's going to give us our answer. And then remember, once we simplify that, we should have an equation that looks like y is equal to a times x minus h. That's just this plus represents the minus. We switch the opposite value. Squared plus k. And so whatever this ends up becoming becomes our k value right here. And then hk is our vertex. All right, let's talk about the process of factoring. Factoring basically is a process of rewriting a sum into a product. So we're rewriting terms that are being added into two things that are being multiplied. Okay, so I'm kind of going to go, excuse me, and use a strategy that I was taught, or that I used to teach this back when I taught high school. It also is using the idea of geometry and area. So let's start out with a simple one to begin with. Y is equal to x squared plus, let's go with 3x minus 4. Okay, so geometrically speaking, if we fill out a rectangle here, we can say that this is x squared, and then the constant goes opposite. Remember, the constant was missing before because it was a square. And the two other corners are going to be what the x's fill in. So we know that there are x's, and they have to add up to 3x. So we use what I used to teach as a diamond problem, and this has to basically multiply. We multiply these two numbers, so it has to multiply to negative 4x squared, and it has to add up to 3x. So these two numbers here have to multiply to negative 4x squared and have to add up to 3x. So if you think about that, that would be positive 4x and negative 1x. Those two numbers are what go in to these missing points right here. And now this is the geometry part. I factor that out. So what factors into x and x is, or sorry, x squared is x and x, and then this becomes negative 1, and this becomes 4. And so this becomes factor of x plus 4 and x minus 1, and that's what it factors to. Then using this, we can go farther and say that the zero product property is when y equals 0, and then x plus 4 times x minus 1. And then the zero product property is when we say if we got two numbers and we multiply to get the answer of 0, either one of those numbers, so x plus 4 equals 0, or x minus 1 is equal to 0, and then we can solve for one of those numbers. Okay, so a lot of this stuff is stuff that we should have learned in 1010. So this is one way of looking at it, and it's the idea of geometry. So a lot of it is the idea of you multiply the first number times the last number. So you multiply these two numbers, and it has to add up to the middle number to be able to factor. Okay, so now I'm going to do another example without doing the geometry part. So let's say we've got the equation y equals 2x squared plus x minus 6. So there's two ways that I teach this without a rectangle. One is called by grouping, and then one is what I refer to as the division strategy. First, let's do by grouping. So we still multiply the first and the last number. So 2 times negative 6 is equal to negative 12. And so I'm looking for factors of negative 12 that are going to add up to the middle number, so that are going to add up to 1. So I've got, let's see, we could do negative 12 and 1. We could do negative 6 and 2. Or we could do negative 3 and 4. Okay, so this works. So what I'm going to do is I'm going to break up x into those two numbers. So I'm going to do 2x squared minus 3x plus 4x minus 6. And I'm going to group it into these two categories. So by grouping, I'm going to look for a common factor. So I'm going to look for a factor that goes into 2x squared and 3x, and that's x, and so I'm going to rewrite this as x times 2x minus 3. And then I'm going to look for a factor that goes into both 4x and 6, and that would be 2, so I'm going to factor that out and bring down my plus sign, so that's plus 2 times 2x minus 3. I know I did this right because these two binomials are the same. So I'm going to write that out, 2x minus 3. And then I'm going to combine these two. So x plus 2, and now it's factored. And so I've got y is equal to 2x minus 3 times x plus 2. Then I'm going to apply the zero product property, just to make sure that I'm comfortable with the idea of solving. So I plug 0 in for y, and now I can say either 2x minus 3 is equal to 0, or x plus 2 is equal to 0. So 2x is equal to 3, so x is equal to 3 halves, or x is equal to negative 2. And so those are my two possible solutions to this quadratic equation. So that is factoring by grouping and then solving with the zero product property. Factoring by the division strategy is the same thing. I actually use this same strategy right here, but now when I find negative 3 and 4, I go right into my parentheses. And I take 2, this number leading coefficient right here, I put 2x into both, and then I take my two numbers that I found into both of the sets of parentheses, and then I look into both parentheses and I see 2 and 3, there's no number that I can divide out, so I leave that alone because there's no number that divides out of 2 and 3. Then I look at 2 and 4. Well, there's a number that divides out. Both of these are divisible by 2, so I'm going to go ahead and divide that, and I get x plus 2, and now it is factored completely. And that's the division strategy. And so that's basically factoring for quadratic equations.